Hi everyone and welcome to this video about arcs and sectors. In this video I'm going to explain what arcs and sectors are, how to find them, and also how we use them in questions. Before I begin the video, remember to please like and subscribe if you've enjoyed it, and also comment down below if you had any questions or you would like me to go through any content in another video for you. So here I have a circle that has been split into segments. We refer to these segments or regions as sectors. A sector is the section contained between two radii. Remember, the radius is where we draw a straight line from the center of the circle to the circumference. So these two straight lines here are radii. This smaller segment here, this smaller sector is referred to as the minor sector. It's referred to as minor because it's smaller than the other one, which is referred to as the major sector. So this section of the circumference that I've colored in pink will be known as an arc. And the length of this pink line here will be known as the arc length. Now we normally use the Greek letter theta to denote an angle that has been subtended at the center. Now subtended just means we've traced out that angle in opening up the sector. So this is the way that I like to think about it. We'll begin with one radius going upwards, and what we're going to do is we're going to twist this radius to the right here, opening up an angle to create our sector. And this angle that we subtend in the center is going to be called theta. So when we're trying to calculate the area of a sector, we need to remember that we've only got a fraction of a full circle. We can think about this by focusing on theta, this subtended angle. For a full circle, we know that we have 360 degrees. Whereas clearly on this diagram, theta is less than 360 degrees. We're going to have a fraction of the total angle of the circle and also a fraction of the total area of the circle. That means I can do theta over 360. Then I can multiply that by pi r squared. This is going to give me the area of a sector. Following on from this logic, we can also say that to work out the length of an arc, well, we're going to have a fraction of the full circumference of the circle. That fraction is still going to be theta over 360 degrees. Whereas before we multiplied by the total area of the circle, now we're just going to multiply by the total circumference, which is pi times the diameter, or we could have written it as 2 pi r. So this formula is going to be the length of an arc. Now, of course, if we were wanting to calculate the area of the major sector, or the arc that is formed by the major sector, we could have simply found this angle here and used that in our formulae instead of theta. Let's have a look at this example question. We're going to find the area and the perimeter of this shape. To work out both the area and the perimeter, we're going to need the fraction of the total circle that we have. The angle subtended by this section of the circle is 40 degrees, so our fraction is going to be 40 over 360. We're going to use that to multiply the total area if the entire circle was visible. So we're going to say that the radius of this total circle is 6 centimeters, and this is going to be the area of my sector. So this works out to be 4 pi. So this is the answer left in exact form. Of course, you can also convert that into a decimal, which is around 12.6. So to work out the perimeter of this section here, well, first we're going to add up the two radii on each side. So the perimeter consists of this side, and my arc at the top. So I know I'm going to need to add 2 of these radii, so both sides is 6 plus 6. And then to work out the area of the arc, I'm going to use that same fraction from earlier, 40 over 360, multiplied by 2 times my radius, times by pi. So this is the answer in exact form. If we wanted the answer in decimal form, it would be 16.2 centimeters. So I should probably add on my centimeters squared to my area as well. Let's take a look at this second example. So we're going to again work out the area of the sector, and we're also going to work out the perimeter of this shape. So we'll start with area once again. we can see that in this case we've got a full circle except we're missing a section. In fact, we're missing a quadrant. Okay, we can see that because there's 90 degrees labelled there. So I know the angle of the missing section is 90 degrees. So the fraction of the total circle will be 90 over 360 degrees. And what I'm going to do then is just multiply it by pi times r squared. The radius of the circle is 0.2. So let's add that in there. And if we work this out, we find this to be 1 over 100 pi. And if we write this as a decimal, we find it to be 0.031. Okay, let's add in our units then. For area, we know that's going to be centimeters squared. So now we've worked out the section of the circle that's missing, we've got to subtract that away from the full thing. So we're going to do pi times 0.2 squared minus our answer, or 0.031. And we're going to find that that is 3 over 100 pi, and if we write that as a decimal, it's 0.094 centimeters squared. And so this answer, 0.094, is the area of the shaded section on the left-hand side. Now, of course, we could have just done the full circle's area times by 3/4. Okay, so well done if you saw that. Let's move on to working out the perimeter. So this time I'm going to do it a little bit different. I'm going to do the remaining section of the shape. And I just said that that was 3/4 of the full circle. So I can use that as my fraction, times by pi, times by 2 of my radii, and that's going to work out the arc length here. Now let's add on these two remaining straight line lengths, and this comes to 1.34 centimeters. So this is my final answer for the perimeter of this shape on the left. Let's take a look at this harder question here. Once again, I'm going to be working out the area of the shape and also the perimeter of the shape. So when you get a question like this, it's important to break the shape down into things that you know. So looking at this shape, we've already got some dotted lines to help split the shape up into manageable sections. We can see that in the center we have an equilateral triangle. We know this because it's been labeled with these 3 slightly bolder red lines. That indicates that those 3 lines are the same length. So to work out the area of the triangle, we're going to do base of 1.5 multiplied by the height of 1.3 multiplied by a half. And this works out to be 0.975 centimeters squared. Now let's work out the remaining semicircle areas. So we know from the bottom semicircle that the radius of each of these semicircles is the same, and we know that the radius is going to be 1.5 divided by 2. I'm going to use a little trick here. I can see that I have 3 semicircles. So instead of thinking about a fraction of a circle that is smaller than 1, I in fact have more than 1 circle now. In fact, I have 1.5 of a circle. We can still use this idea of a fraction from earlier, and now instead of writing the fraction over 360, I know that I can find the area of the circle and times by 3 over 2. This is going to work out the area of all of the semicircles, and this works out to be 2.651 centimeters squared. So combining these two numbers now, we get the final answer for the area of the shape, which is 3.626 centimeters squared. Now let's move on to the perimeter of the shape. This is going to be slightly easier because we can ignore that triangle in the middle. So we can see that we've got the 3 semicircles, or the arcs of those semicircles. That is what forms the perimeter of my shape. So let's use this fraction idea from earlier, in which we use the 3 over 2. The 3 over 2 represents the fact that we have 1 and another half of the same circle, so we can again use this idea of the fraction. We're going to multiply by the circumference of one of these, which is going to be 1.5 times by pi. So in exact terms, that is 9 over 4 pi, or if we convert that into a decimal, 7.07 centimeters. Thank you for watching this video. I'm glad you've made it all the way to the end. If you have any questions about the video, remember you can leave them down in the comment section below. Please like and subscribe if you enjoyed it, and I will see you in the next video.